Hello and welcome. Thank you everybody for attending our Zebra Dev Talk today. I just wanted to kick it off. My name is Stacy Kruzik and I am the Dev Marketing Lead for the Dev Relations team here at Zebra Technologies. We have a very special guest today. IOTA is here to join us today on this talk. It's going to be incredibly interesting, and we're appreciating everybody's time and effort to attend this webinar today. Just to go over a few housekeeping rules and a couple of tidbits that you'll probably want to know about. We would love for you to be a part of our community if you are not already. It's free to join. You can go to our developer portal at developer.zebra.com. Go ahead, join us, register, play in the sandbox, look at all of our different various blogs and everything on enterprise development. And we encourage you to join at any time. We also, if you join, you can go ahead and join the community to receive our invitations to these Dev Talks moving forward. And then we also have our DevBuzz newsletter. This comes out monthly. It's chock full of information related to many of our products and building solutions for them, introduction of APIs, SDKs, things of that nature. And we encourage you to participate in that as well. Follow Zebra. We're on Twitter, LinkedIn, GitHub. And we are actually in a LinkedIn community group. It's a private group, but anyone can join. It's all things developer and informational there. Our Twitter account is @ZebraDevs. We're active, we're online, and we're always sending out information to our developer community. We invite you to join us there as well. We're excited to announce that we are, fingers crossed, we will be live in person in Q4 for our Zebra DevCon 2021. This is coming in November. We expect to be live in Madrid for our developer community with a possible live feed to the other regions that aren't able to attend. So we're hoping that everything is moving forward in our world and we will all be able to see you face to face because we miss seeing you all. So that's the first thing. So watch for information about that. It'll be on the portal, DevBuzz, and our Dev Twitter account. And with that, today I'd like to introduce that we're going to be talking about the IOTA track and trace APIs. We have Robin West, who's going to kick us off from Zebra Technologies. You all probably know her very well by now. Jens is joining us, and Jose from IOTA. And I just want to verify that one other housekeeping rule is that we usually take questions at the end rather than during the presentation. There is a Q&A type box, a live chat, if you will, on our presentation today, and I will be monitoring that, and at the end we can take all of your questions. We will also be recording this. So if for some reason you need to jump off, or there are other people on your team that may want to see this, or you might want to send this out, we'll have this recorded. We have a YouTube playlist, and we're happy to share that information there as well. It'll be up on that YouTube playlist within the next week or so. So with that, I'm going to go ahead and bow out of here and let Robin take over.
Thanks, Stacy. So today we're going to be talking about the IOTA track and trace blockchain ledger solution that we are essentially providing access to through the Zebra Data Services. So what is Savanna? I'm not going to go into too much detail on this. We've covered it in a number of other previous sessions, but essentially it's a platform for access to data, both from devices, from different cloud-based storage solutions, and from Zebra itself, and provides you access to that data and analytics off of that data in order to make it easier for you to actually do your jobs and get that information into your applications and services. So the data services are that access point of how do you get access to the data that we are providing through Zebra Savanna. The data itself, it comes from a number of different sources, as you'll find out a little bit later on in this session. Some of the data is coming from the Zebra devices directly, some of it's coming from our own data lake, some of it's coming from different applications within Zebra, and some of it's coming from our partners out in the world. IOTA is one of them, but IOTA has been a great partner for us, and we want to kind of show you why that is as we go through with this conversation. But essentially, from the standpoint of data services, these are the APIs, the RESTful APIs that you can use to interact with our different data points and do a bunch of different things. So obviously I'm going pretty high level. This is a really high level architecture of how this works from the standpoint of, different devices are pushing data up, both data about the devices themselves and data about what it is that it's accessing. Because most of the Zebra products from a hardware standpoint are accessing data points around things like shipping labels and item level labels and that kind of thing, either creating those labels or getting the data off of those labels and providing that to the customers. So what we're doing is we're adding an additional layer to push that information up to Zebra Savanna, the cloud, and providing a bunch of different service access to be able to interact with those devices and those data points, either on our back end or on our partner back ends. And it all kind of flows together. It's a lot of back and forth, and we have a number of different services that interact in different ways through Zebra Savanna to get you the information that you need when you need it. So we do have several services available already to interact with our Zebra devices. Things like Send File to Printer and Cloud Connect for RFID. Send File to Printer gives you the ability to send configuration files, print files, and RFID encoding files to the printer, get them to be printed, encoded, and handled in the printer, and be able to send that and do it securely through the cloud. Cloud Connect for RFID is actually a collection of several different services. It has services to allow you to uh, configure and work with that reader, a fixed reader. It also has services to allow you to have it push, as we were saying, push the RFID reads, the tag data up into the cloud and decode those and make that easier for you to access and work with. And it also has some services for, once you push that data up to us, the tag data up to us, storage and access to that storage and analytics off of that storage that, we would have on the back end if you'd like us to do that. And then Visibility IQ is a set of services around, a large set of services at this point around the mobile computers, the scanners, the data around the actual device and how it's interacting, how it's being used. Things like giving you notifications when the battery is swapped or other different issues like that. So that gives you access to that sort of data through the Visibility IQ Foresight APIs. So that being said, being that we've got a number of these different services already to interact with, work with the devices, we're going to talk a little bit about how that works with IOTA because, okay, we've got the visibility to the devices, and now you have to think about how it's actually going to be used in a actual, workspace and workflow out in the world where you have to do traceability. So, our things are on the edge, our devices are on the edge, and they are interacting with the different products on a regular basis. As each time it goes into a dock or into distribution, it gets scanned and tracked. So in the past, this has been the tracking of those products have generally speaking been pretty much siloed to each of these different points that we're looking at here. So in the manufacturing, they're tracking everything about what's going on with that product within the manufacturing facility. And then they throw a label on it and it gets shipped off. And yes, you can track it with that label number, but a lot of times that doesn't actually work all that well. And there are a lot of times where you don't know what's happening necessarily within another facility. So, and sometimes you need to know that because of different use cases. So the concept here is that each of these different areas tends to be fairly siloed as far as its tracking within that facility or within that infrastructure. Or within that corporate infrastructure, I mean. So they know what's happening within their own facilities and their own infrastructure and what, where the product is and what's going on with it. But once it leaves their doors, the amount of information they have on what's happening to it is really pretty low. And they don't necessarily know what happened to it before it got to their facility. So that leaves a pretty gaping hole for a lot of customers to be able to figure out, to try and say, if something happened to the product in between point A and point B, I'm not sure that I would know. So that's where some of these traceability applications and systems come into play. And one of the reasons why we're working with IOTA to work on blockchain traceability. So that's the long and short of very high level of how this interacts and plays. We are providing the device connectivity and the access to that data from both the devices and the labels and tags and other things that they're interacting with. And what happens to that data afterwards is a little bit up to you guys from a developer perspective. But one of the options is to be able to utilize IOTA track and trace in order to be able to do that traceability and figure out a lot more information about what happened to that product as it's flowed through a bunch of different corporate entities and facilities, in order to have a much better understanding of any issues that may have cropped up in there, so that once it gets to the customer, whoever that customer may be, there's a much better record of what happened to that product, and can be traced back if needed to determine what went wrong. So with that being said, I'm going to hand it off to Jens Munch, and he'll be telling you a little bit more about IOTA and what they're doing. Jens? I can't hear him.
I think I'm online now, I hope. So sorry about that, everyone. Thank you very much. Thank you, Robin, for the introduction. Am I sharing my screen? I am. Thank you very much. Here we go. So yeah, my name is Jens Munk. I represent the IOTA Foundation, and I'm heading up our work around using DLT for supply chains and trade use cases. And very happy to share this with you today. And thank you very much for the invite to Robin and the Zebra Corporation. Just a few words about who IOTA is. We were funded in 2017, but actually the project started out back in 2013. And today we're one of the leading research and development organizations around distributed ledger technologies, working with many corporates, academias, and so on to take this technology into adaptation and real use cases. And today we're going to talk much more about supply chain and track and trace, as Robin said. And what I will do is just give you a brief talk about what we see as use cases that could be relevant for you. And I also have the honor of giving a short presentation on what is a blockchain distributed ledger? Why is it relevant for these use cases? Just very briefly, I will try to explain how this technology works as a starting point before I hand over to my good colleague Jose, who would be much more hands-on. But basically, if we just start, I think, Robin, actually, you gave a very good description of what happens in a supply chain with these multiple siloed information and many actors. I sometimes call it black boxes that, each actor actually are in their own black box and they don't see what's happening further down the value chain or up. And information are getting rekeyed into new systems and so forth, reused, prone for error, or maybe not available at all. So that problem, actually, we could create a lot of use cases, and what we see people are using or doing in supply chains, the typical use cases is visibility of where the goods are, location-wise. That's for better planning, better coordination among the different supply chain actors, just-in-time, recalls, predictions, and so forth. Or it could be to get specific data around an item, where does it come from? Can I get the certificate of origin? If I had a preferential trade agreement, I have to cross a border. Ethical use cases, actually data that can travel all the way to end consumers who can find information about how a product has been produced, who was it produced by, who has been hands-on with this product through its lifetime, and then product authenticity, wine, olive oil, luxury goods, spare parts, and so on. Is this authentic? The fake market is pretty big out there, and it's a huge problem. And the missing pieces to actually make this work is really, we need to give a product a digital identity so we can start to manipulate it. And many of these identities will need some kind of tag in the real world that we then provide the digital twin for. Whether it's a QR code, a barcode, or RFID chip and other tags out there is one of the missing points, and why this partnership with Zebra is a great connector of different competences. But we will also need to be able to have this data accountability, that you can actually trust that data that it comes from a source. You know who provided data when you start to share this in an ecosystem, and you might know those partners directly, but you want to have data accountability and data lineage back to who's issuing data. And then, of course, the data immutability, the fact that you know that nobody can forge this data as it is getting shared, and people are reusing the data, that it can't be falsified or manipulated at a later stage. And the distributed ledgers or blockchain is that technology that can help with these missing pieces. So to get that logic going, I'm just going to say 2 words on what is a blockchain. I'm sure a lot of you already know that, so forgive me for this, but very quickly, the traditional way that you have trust systems in our society is that we have some kind of centralized clearinghouse where people would, or institutions or organizations will share data to a central database, banks, governments, and so forth, and they will keep the ledger. So they would, if it was a bank, they will keep, your account. If you pay something, they will update your account on this, and so forth. And they provide the trust. They keep the ledger. They have full control, and other trust unit in this. But when you start to talk about distributed system, it's a little bit different. There, the information is not stored in a central place, but is actually distributed. Many entities will keep the ledger, so to speak, and imagine everybody sits with a block of paper. That's the simple explanation, and keeping a ledger. I pay €10 to Robin here, and she pays me €3 back, and everybody notes down. And then the truth is, what is consensus among all of us that keeps this ledger. So the truth is the 51% minimum agrees. And once you start to think about distributed systems that actually, there are many nodes out there that are all doing this, then you start to understand how how difficult it is to attack these systems. And it actually adds to this is that data is stored in what we call blocks. That means that a set of information, actions, transactions will be stored in a block, and then a new block would be stored by all actors. But that new block would reference a fingerprint of the previous block, a unique fingerprint of the previous block. And then the new block would then reference a unique fingerprint of that block. And that means that if you, let's say 7 blocks later, wants to try to change some data that earlier came into the system, you will not only need to change that transaction data at that time in that block. You would have to change all transactions following that block because they're all referencing that original block, and thereby you have this immutability of data, and that we call it data trust, right? So you can use this in a supply chain event, to upload the time or the date of something, information, the who did what, and that way you ensure the integrity and the accountability of this data. You can actually add encryption layers. We have different encryption layers that you can get out of the box of this data. So you can start to permission who is allowed to see what, and therefore you can start to organize business sets up in business logics in this. So when we talk about IOTA and distributed ledger technologies, we are actually not a blockchain, because blockchain has some inherent problems. Classical blockchain. I mean, if you look at the most well-known like Bitcoin and Ethereum, they can, due to the block formation that I have to do on the underlying protocol, they can do 15 transactions per second, and that is not enough for a supply chain ecosystem. Furthermore, there's a need to have many nodes running, and all these nodes in classical blockchain are provided by miners. So in return for doing this work, they need to be incentivized. So you have to pay a gas or a fee for storing data on these blockchains, and that means you basically have 2 types of users in these scenarios. You have the users that actually use the blockchain, and then you have the one who provide the infrastructure, and therefore there could be conflicting interest of what is the fees for this, and miners will tend to want fees, preferably as high as possible, whereas normal users who use for data would want it as cheap as possible. So we have solved this problem in a fundamentally in another data structure, that where they have no blocks and there's no chain. So it's not a blockchain. And it very short. When a new transaction comes in, and I'm trying to show the Tangle here on the right side, and a new transaction comes in from right, it will reference 2 previous transactions that are randomly chosen, that then will reference 2 previous transactions, that will reference 2 previous transactions, and so forth. Like blocks will reference previous blocks. So we ensure this immutability through another protocol. But the interesting thing is here that you as a user, when you're referencing 2 other transactions, you also take the verification job on you. So you don't have users on one side and miners on the other side. And that means that you inherently help other users' transactions to become immutable, and therefore there are no fees, because whenever you need to post something on the Tangle, you are also helping the system to secure other data on the Tangle, and so forth. So the cost of the running this is the underlying infrastructure, and the CPU power, if you like, which is much smaller than what you see with most blockchains. So this is the way we enable I'm just gonna see it won't load. This is how we enable immutability. This is interesting. Apparently I can't load this slide. I'm not sure why that is happening. But we'll try here. Yeah, so there was some part of it wouldn't show. But basically, I can see I'm missing some graphics here, but you will definitely live with this. So this protocol has some very useful features, and one of them is it's much more scalable. At the moment we run 1,000 transactions per second on our mainnet, and if you spin up private versions, you can run more just for data, and we expect this to grow quite a lot this year. And then there are lower energy requirements and the zero fees I talked about and so forth. So all these are some features that you could actually use when you start to build supply chain use cases. And the road to realization and using this technology in supply chain is really, in our opinion, to ensure that there's an infrastructure available to read this data, to push this data to the Tangle, and build applications on top of that. And that's where this partnership with Zebra comes in and becomes very powerful, because that infrastructure is built out with Zebra devices around the globe. And what we have done here, and this is where I'm going to hand over to you, Jose, is that we're showing how you quite easily can use these devices, use the Savanna API to put data onto the Tangle, and then start to build business models of there. So thank you. I'm going to hand over to Jose to take you to this much more hands-on. Thank you so much.
Okay, let me see. We're going to go ahead and move over. One moment, we're just trying to. Sorry, trying to see if we can move that. Just a little slow today. Did that work?
Yes, hello. I need to share my screen.
Okay. I believe the screen is available now. Let's try this again. There we go.
Okay.
Just a little bit of a delay today. Thank you.
Thank you. So, hello, my name is Jose Cantera. I'm tech analyst and project lead in the IOTA Foundation, and I'm technically leading the track and trace ledger APIs work. So today I'm going to present the APIs from the point of view of a particular use case. As Jens mentioned, there are different use cases where all the traceability that can provide Zebra devices can be applied to the supply chain. But here we are going to focus on a particular use case, which is sharing all the event visibility data for parts in manufacturing. And of course, we are going to use the blockchain technologies to share trusted data, trusted and immutable data. So the use case have three different stakeholders. We are assuming that we have a part supplier which has a factory which is producing the parts. We have a warehouse, an intermediate warehouse in the part supplier facilities, and we have also the manufacturer factory. And what we want to do is to share the different events that are happening at the level of a particular part, at instance level. That is a very, very important point, because we are going to do things in that level of granularity. So we assume that at each of the facilities, we have readers, we have scanners, or we have even printers, and all the events that are happening with a particular part are going to be recorded on the blockchain, on the DLT, on the Tangle, in this case, in IOTA. So here you can see that one of the parts have been produced. It can be labeled, or it can be read by a reader or by a scanner, and it will be recorded on the distributed ledger. How it is recorded? Using a JSON data structure that captures what is the part, so the ID. The ID is an EPC as per the GS1 standards, the timestamp, but also other interesting data like location. Furthermore, in future versions of our APIs, we will include also the identity of the producer of the data, and we will see later that it would be very important in order to ensure non-repudiation of the data and authenticity of the data. Afterwards, the part may arrive to the warehouse, and at the warehouse, another scanner or reader will detect the part and also will generate another transaction to the distributed ledger. You have to take into account that this transaction is linked to the previous transaction, and the data in this second transaction cannot be changed because it is in the same link as the previous transaction, and it happens the same with the initial transaction. So this data, you need to understand that it is secure on the distributed ledger. But furthermore, there can be a third participant in the supply chain that is also contributing to the supply chain trail, and in this case is the factory. And the factory, when the part arrives in the factory, a reader detects it as well and submits another transaction to the distributed ledger, which is linked to the previous transactions, reflecting the fact that the part has been received and it is now at the factory. And you can see that all these transactions, all these pieces of data are represented using JSON format. And as I said before, it covers what is the device, what is the part, what is the identifier, what is the timestamp, what is the location, and also, as I said before, the identity of who is generating the data. And how this can be done? Well, this is what the track and trace ledger API is providing us. So using the track and trace ledger APIs that we have developed, is very, very easy to build these supply chain trails. Why? Because from the Zebra devices, there is the API, our API layer, that automatically is able to detect the events that are being produced by the Zebra devices and capturing these events and sending them to the distributed ledger, to the Tangle. So this is how it really works. So the API implementation, which is this yellow box, is an intermediary between Zebra devices and Zebra Savanna that was explained before by Robin, and the IOTA Tangle. And the good idea and the good point about this is that you, as a developer using Zebra devices, as a developer very used to web APIs, to JSON format, you don't need to take care about the integration between your applications and devices and the blockchain technology. You can do it very easily through the track and trace ledger APIs. And the IOTA integration service, which is the core of the APIs, takes care of generating the different streams of data into the Tangle, of organizing the data into the blockchain, and also having the different indexes that allows to retrieve the data on the Tangle very easily. But furthermore, if you want to go directly through the IOTA APIs to the Tangle to get this data, to read this data, you can do it. However, for generating data and writing data, it is always done through our REST API service. So that's an important point to take into account. How this works is very easy. So if we think about a Zebra device, a reader, you have a device event from this reader. That device event goes to the Zebra Savanna. Here, the API that is in between the blockchain API and the device is the RFID Cloud Connect, which is the link between the two. And once the device events arise into Savanna through RFID Cloud Connect, then a post is generated to the Zebra IOTA track and trace ledger APIs. This post comes with the data that I showed you before in the previous slides, and it is sent as a transaction to the IOTA Tangle. And when you want to get the data, the inverse operation happens. So you query for certain data, and we will see that the data can be queried, for instance, by device or by EPC. You get the data, the transaction data, and you, as a result, you could obtain the supply chain trail about a particular part in your supply chain. So this is very powerful, and you have to understand from the initial slide, which is very important, that thanks to the blockchain technology, these different actors in the supply chain can share data between them. So the factory can know where the parts are, or what happened with a particular part in the supply chain. So the transparency and trust between the part supplier and the manufacturer factory is actually increased a lot. So this is the summary of how the API works, but now I would like to show you the API working in real. So we are going to switch to Postman, and I'm going to show you how it works. As I said before, when a device is sending data to the Tangle, it has to do a post to a particular endpoint, the endpoint that you can see here in Zebra Savanna, and you can see here the payload that they were showing in the previous slide. Okay, in this payload, we are now focusing on a particular spare part identified by this EPC, and we are going to send the post to the API. And as a result, the API, which acts as an intermediary between your applications and the distributed ledger, will generate the transaction. So here, I'm going to send the transaction. And now the transaction has been recorded. And as a result, I get a transaction ID that I want to query right now. So the same as you can send data, you can also retrieve that data if you know the transaction ID, for instance. But not only that, as we will show. So here. Sorry, because there could have been, I could not have pasted correctly the transaction ID. So this is the transaction ID. Excuse me 1 second. Okay, there was. now we are retrieving the transaction. I missed the URL. And now we have the transaction. The transaction, as you can see, has been enriched with certain data that the API has added automatically. So you can see here a timestamp. So this timestamp is the timestamp that is set by the API, and it is recorded on the distributed ledger. So for instance, if some manufacturer or some participant in the supply chain sends a false timestamp, no problem, because we have the real timestamp that was put by the API. Another interesting thing is that we can read automatically from the IOTA Tangle the data that we have just sent. So why? Because once we know the transaction ID and we query it through the API, we can get also the side key associated to our transaction. Why? Because our transaction data is encrypted on the distributed ledger. So we ensure the confidentiality of the data. So if I get this transaction ID, which is this, if I get as well the side key, you can see here our data that has been recorded on the IOTA Tangles. This is the IOTA Tangle Explorer tool that allows to retrieve the data or allows to browse the data that is stored on the distributed ledger. It is important to note that the data is stored on the DevNet in the current Sandbox API version, but in a future production version that is planned, this data will be stored could be stored on the public net, but also could be stored on a private network devoted to Zebra customers or any customer that wants to use these APIs. And that is important because it implies that the data could be retained as desired by the customer policies. But here in the DevNet, the data could disappear after a few weeks. So we have our first transaction, and this is the first step in our supply chain. But how we can just send the next step, how we can just generate the next event, sending another post. So we can send another post using, in this case, using a different device. So this is our new device. And remember that the EPC, of course, has to be the same. So here is our second transaction. The second transaction will be the transaction that marks the point at the part manufacturer touch point warehouse. Okay, so this is the second one of our transactions. We will send the transaction. Of course, this is with a different device. This is, but of course, this is the same EPC. Remember that we are using the same spare part. So the EPC has to be the same. We send the transaction. And now the transaction appears here. Remember that we are building the supply chain trail, and this is another step in the trail that has been recorded in the distributed ledger. And you can see here the new device. You can see here that the spare part ID is the same ID, and you can see here the timestamp. But of course, you could want to query the same data using the REST APIs. Imagine that here the manufacturer in the factory wants to query and to know what is happening with a particular spare part. That is easy with the API because we can retrieve all the read transactions that have been generated with a particular EPC with a particular spare part just using a GET HTTP request. So if we go to our spare part, which was this one, and we do this, arrest. And here you can see the two transactions that now are part of our trail, our supply chain trail. So this is very, very powerful and very simple for the developer. And imagine that all your devices sending these transactions, and you be able and securing this data on the distributed ledger and using just a REST API to consume this data from your application. This is really, really powerful. There is another functionality which is very interesting as well, which is the capability of querying data that a particular device has generated. This is more from the point of view of each of the participants in the supply chain for purposes of auditability of what their devices are doing. So I can query what a device has been reading from the distributed ledger. So I can obtain this information, and I have this device, and I can query what transactions have been generated by this device. And if you remember, this was our first device in the first touch point, which was the spare part factory. And here you see only one transaction because my device have only generated one transaction. Imagine what could happen if the same device, with the same device here, I generate a transaction but for a different spare part. In that case, which is what I'm doing here, I'm now using a different spare part. So let's use this, but the device is the same. I have generated a new transaction, and if I want to retrieve the transactions that have been done with this device, now I have two different transactions. As I said before, this is something more for auditability purposes of one stakeholder, but of course it's also a very interesting functionality. So having made this demonstration, I would like to return to my presentation and just recap on certain features that our API and benefits that you can have while using our API. First of all is this event visibility data that make your supply chains more transparent, and you have confidentiality and integrity guaranteed, and authenticity and non-repudiation that will be available when DID is integrated. We will talk about DID, which are decentralized identifiers, and we will talk about it in a future seminar next month, so stay tuned about that. So another important fact is that the API is very generic and multiple sectors can benefit. So we have talked about industrial manufacturing, but the retail domain, pharma domain, you can think about distribution center, retailers, manufacturers, all the different actors and different setups in supply chains could benefit. The deployment model is very flexible. You have it as a service now in Zebra Savanna, but you could deploy it in a public or private cloud. An important point is that we make blockchain and DLT easy for web developers and ISV integrators. You as an ISV integrator can very easily get access to this technology. Another point is that we have flexible and deployment of the blockchain with IOTA is very easy. You can even deploy a private IOTA network in AWS with one click. And IOTA provides also technology that allows you to define your data retention policy. So you need to store your data for several months. You could do it. the data that has been generated on the DLT for auditability purposes. And finally, it's important, the interoperability. So we are going to support the GS1 EPCIS 2.0, which is a standard that is going to be ratified in the coming weeks. And the standards that we are using from W3C are aligned with the recommendation of the World Economic Forum and the European Commission through the EBSI, which is the European Blockchain Services Infrastructure. We have a roadmap. So initially, you can use this version for proof of concepts, and it is free for Zebra developers. It is evaluation and preview ready, and for proof of concept ready. We have a roadmap. So by the end of March, we are going to have a pilot-ready version, which is going to include identity and the capability of non-repudiation, and also the definition of the data sharing policies, which is a very important aspect. So you could define to whom you want to share your data, who can read it, who can write it. So all these kind of data sharing policies. We plan for mid this year to have a version which includes full item level tracking with all the different visibility events and documents associated, the status, parent-child relationships, and finally have the API ready and available as a full solution. But of course, this cannot happen with us alone. We need for your continuous feedback from the market, from application developers. That's why we are very open to work in projects, in customer-specific projects with these APIs, testing these APIs, because would allow us to refine the product and our ideas. You have developer resources here. So you have the specification in OpenAPI, you have tutorial, Postman, collection, JavaScript code to play with. And any technical follow-up, please, you can write us in iota.stackexchange.com, which is a platform similar to Stack Exchange, to Stack Overflow for asking questions, and you can contact Jens or Alex from Zebra regarding business opportunities. Thank you very much for your attention, and happy to respond to questions as the other panelists.
Yes. Thanks, Jose. We do have quite a few questions, and just as a follow-up to all of this, anything that you need to ask the developer rel team, we can go ahead and forward that on to the right resources through IOTA and our Zebra development team here. And that's at developer@zebra.com. So just a quick reminder on that. Let me look at the questions here, and then you guys can decide who's going to take this on. Mark has asked, since many of these transactions are financial in nature and typically require rigorous treatment by the system of record and practice, do you expect that some level systems integration, will be needed in most cases so that the transaction can be validated prior to posting the Tangle database?
Yeah, I can ask that one. Yes, so one of the principles that it has to be taken into account is the blockchain has to work with data that is properly validated. So in a blockchain, you put data that is like garbage, you will get garbage. So all the transaction data that has to go into the blockchain, into the ledger, has to be properly validated as per the corresponding business rules. And at the moment, it's not part of the API, this kind of rules, but you can integrate your system with the API, and these systems can send data to the API that makes or it is validated from a business point of view. But of course, the usage of the GS1 standards also allow the data to be more, I would say, more clean up and aligned with the standards.
Okay, great. A few more questions here. Matthew has a couple. The first is, before you use the APIs, do you need to be authorized with bearer token or some type of authentication?
We are actually, you can actually get a key through the Zebra Developer Portal to access it. It's a basic key. This is primarily just because this is a sandbox for proof of concepts. In the future, once it gets closer to production, definitely there will be higher level authentication to access and utilize these. But right now, it's going through just a basic key that you can use to work with these services, and you can get that off of the Zebra Developer Portal.
Okay. Last question. Let's make sure I have this clear. It's a bit jumbled. So the MC33R would post the data transactions with the EPC data, et cetera, to a server. And then the server will use the REST API to IOTA Tangle. That is the question.
So here there are two possible setups. One setup is if you have a reader like the FX9600, it is enabled to work with RFID Cloud Connect. So your data will arrive into Zebra Savanna, and Zebra Savanna will forward to our service. So you don't need to do anything in that way. But you could also have a reader that or a scanner that it is not enabled to do so, but easily you could create an application, for instance, in a scanner in Android that do the post to our API with the data, and we receive the data. So the API setup is very, very, very simple. So either you have a device that is already enabled, or you build something on your device that enables to send the data to our API, to our intermediary.
Yeah, currently the only devices that we have that are directly able to push data into this are the fixed FX readers, but that I'm sure will be changing very quickly. But right now it's the FX readers that can push directly. Other than that, you can interact with the devices either through a local application or server, like Jose said.
Okay, great, good. Let's see, a question just came in. If I want to revoke access after I already provided someone with root and side key, can I do that? Is that allowable?
That at the moment, no, but this is something that we need to address in the data sharing policies. So it's an important point. It's not only allowing you to share the data, but also to allow you to say, I will no longer, I don't want no longer share the data with this stakeholder. But that can also usually be done as well by creating a new channel. So all this data in the ledger is organized into channels, and these channels can be, I would say, created, or you can create a new channel, and in this new channel you start putting your new data, and as the original stakeholder that you were originally sharing data with has no longer access to the new channel, you will actually revoke in access. So there can be, this is a mechanism that can work very well for revoking access, which is I create a new channel, so I create a new supply chain trail, and then this guy no longer has access to the data because he does not know the new channel.
Okay. Moha came in with another question. If I change the side key in the future, that particular root will always be exposed to the person I shared that with. That was the statement, apparently, right?
So the principle is, so essentially the side keys are managed by the API, but of course there is a mechanism that through the API allows you to know this side key, provided that you have the proper data sharing permissions. And this is, of course, an agreement between the different participants. So it's something that it is known by the different participants in the supply chain. And it's the same, similar, fixing that issue is the same as the previous. So if I want to stop sharing my data and the other guy knows the side key, what I need to do is create a new channel. I create a new channel, and that new channel will have another side key. That would fix the issue, and it's a similar issue than revoking access.
Okay, just going to give it a second here. I said thank you so much. But Matthew came up with another question. Is there data recovery with Tangle in the event of a catastrophic disaster? So if Zebra Savanna server went down.
Yeah, so the great advantage of the distributed ledger is that there are different nodes, and these nodes, as Jens mentioned in his presentation, have essentially the same information. So in case of something happens, there is a node that has the data. Also, there are procedures to do backups to these nodes, and also there is the option of permanodes, which are named in IOTA chronicle nodes, which can store the data for a long period of time and also can serve as a backup facility. So there are different options to recover the data and to ensure that the data is going to be recoverable.
Yeah, and if it never makes it to the ledger, we are able to keep track of, at least for a short term, the transactions that are coming through Savanna. If it never actually makes it even to Savanna, they're building in, it's not quite there yet, they're building in some services and capabilities to get access to the data, the transactions that happened on the reader as well. That's not quite there yet, but we do have that built into Savanna, and obviously from a blockchain perspective, that's generally not going to be a problem. Or from a ledger perspective. I apologize.
Yeah. Okay, I think that's it. And I want to close this out to thank IOTA for coming on and joining us today. It's always a valuable experience to share these talks with the entire audience. So thank you to you for doing that, and thanks to Robin as always. So with that, I wish everyone well today. Stay warm or cool wherever you may be. And we'll look for you at the next DevTalk in February. Cheers.
Thank you, everyone. Yes.
Thank you. Bye.
Thank you so much.